A particle P moves in a straight line so that at t seconds, its acceleration is 3t meters per second squared. So let's straight away say that a is equal to 3t. Given that P passes through O when t is 0, with a velocity of 2 meters per second, we want to find the following. So what we're being given here is that x equals 0 and v equals 2 when t equals 0. And that's going to enable us to work out any constants that come up. So in part A, velocity is going to be the integral of 3t dt, which is going to be 3t squared over 2 plus a constant which I'll call c1. Now we know that v is equal to 2 when t equals 0. Substitute that in and we get 2 equals 0 plus c1. So c1 equals 2. And therefore velocity is 3t squared over 2 plus 2. So now we want an expression for the displacement if we're going to find distance. So x is going to be the integral of the velocity. So 3t squared over 2 add 2 dt. So that's going to be 3t cubed over 6, because the 3 goes onto the bottom, add 2t plus a constant which I'll call c2. So x is going to be t cubed over 2 plus 2t plus c2. And we know that x equals 0 when t equals 0. That should be reasonably clear that c2 is 0. And so x is just going to be t cubed over 2 plus 2t. And we want x of 3. So that's going to be 27 over 2. Add 6, which is 12 over 2. So that's going to be 39 over 2 meters.